Okay, this is 7.1. This is the first section of Chapter 7, and Chapter 7 is all about linear systems. The whole chapter is about systems. So it's going to be really important to know what a system is. Let me say this again. The whole chapter is about systems. So if I ask you what a system is, you should be able to answer, well, system of linear, we're going to have lines. Linear equations. Equations means multiple, right? The S means plural. So a system is just that. Two or more equations that have the same variable. Now, what are your two favorite variables? X and Y. Honestly, just two equations that involve X and Y are considered a system. So y equals 2x plus 4 and y equals negative 3x plus 6 would be a system. It's two equations. They're both using the same variables. Yes, you will, for the most part, always see x and y. Now, sections 1, 2, 3, and 4 from chapter 7 are about solving and the different ways to solve linear systems. So it'd be really nice to know what the solution actually is. And the solution is the one ordered pair that works in both systems, because each equation here has its own table of input and output values, x and y coordinates that actually work in the equation. The solution to that system as a whole is the one ordered pair that both equations would have, because that ordered pair would work in both equations. It would work, it would be consistent. The next vocab term, the key thing is that there's one solution. We aren't really going to use that term ever. Okay, here's what you're going to do today. 7.1 is solving the linear system by graphing. So the first thing you have to do is graph both equations, but you graph them on the same coordinate plane. So one coordinate plane, two lines. Coordinate plane, and you are going to draw two lines. Now, you know how to draw linear equations. Now, you are going to solve this system by finding that point of intersection. Where do they cross? Well, it'd be right here. Right here is where they cross. That ordered pair is your solution to this system. And then we do a quick check, does that actually work in both equations? Now, graphing equations. We've done this in a couple chapters now. At this point, you should just be able to do it. That was me snapping my fingers if you can't hear that. So in example one, we're going to solve the linear system, and we're going to do that by graphing. But if you look at the equations, 3x plus y equals 9, and x minus y equals negative 1, those are both going to be pretty hard to actually graph, because it's a lot easier for us to graph in slope-intercept form. So let's put them in slope-intercept form. The first one, equation 1, we'd need to get the y by itself by subtracting 3x on both sides, and y equals negative 3x plus 9, and then I would go to graph that. My graph is going by 2's, so 9 is actually here, where this is 8 and this is 4. If I go down 3, that's actually putting me at 6, and then over 1, those are going by 2's as well, so it's actually here. Down 3 and over 1, down 3 and over 1, down 3 and over 1. Now I'm going to give a very, very strong recommendation. And my very, very strong recommendation is be very, very good about, oh, you know what, I don't want that. Be very, very good about your, let's just use that one, about your straight lines. You should be using a straight edge when you go to graph these lines. So I'm going to need to adjust this, which is not the easiest thing, actually. Come on now, bud. There we go. All right, so I got my points all lined up, right? Well, I'm a little bit off, but here we go. So I'm going to follow my straight edge, follow my straight edge, following my straight edge. So there is the line of my first equation. Strongly recommend a straight edge here because your graph is going to help you find the solution. Be really nice if, there we go, be really nice if that were an accurate graph so you could have an accurate solution. Let's graph line number 2 now. So I need to get the y by itself, subtract x from both sides, negative y equals negative x minus 1, divide by negative 1, and y equals x plus 1. And when I go to graph that, 1 would be here, up 1 over 1, up 1 over 1. If you draw enough points, it is pretty likely that you will be able to, I need to go this way, that you will be able to find the ordered pair that they have in common, actually. Because did you notice that I actually drew right over one of the current points? That's the point they have in common. So there's my straight line. And now I know the ordered pair. So the point of intersection, the two lines appear to intersect at this point right here. And that's at 2. And then since it's between 2 and 3, the y coordinate would be 3. My answer is 2, 3. Take a second, make sure that works. Well, 3 times 2 plus 3. Does that equal 9? Yes. 2 minus 3, does that equal negative 1? Yes. That is the one ordered pair that works in both those equations. All right. Oh, example 2. Oh, and this is your check. Isn't that a ton of fun? Notice that we just kind of did a mental check, but 2, 3 would be the solution. All right, let's do this again. Let's get me my ruler again. There we go. Okay, so your checkpoint. Let's solve the linear system by graphing. Let's get 4x plus 2y by itself, get y by itself. I would strongly recommend starting to be able to do some of this mentally because otherwise this is going to take you a long time to solve. So negative 2x plus 3. And so that line would be need to adjust it just a scotch. There you go. So that line would be here. Following my straight edge. Yeah, there we go. Save that for my next equation. And my next equation is 3x minus 3y. And that would be negative 3x plus 9. Divide everything by negative 3, and that's x minus 3. And up 1 over 1. Hey, look, I already found my ordered pair. Because if you draw enough points, you probably most likely will get, there we go, will get that one answer. So let me make sure this is, yep, lined up beautifully. Let's draw my straight edge. Beautiful, beautiful. And my solution would be the one ordered pair where it crosses. This ordered pair is 2, negative 1. And there's my answer. Let's take a second to make sure that that works. 4 times 2 plus 2 times negative 1. And yes, that is 6. 3 times 2 minus 3 times negative 1. And this one gets tricky because that's actually 6 plus 3, which is 9. So that is one ordered pair that works in both equations. Checkpoint 3, same idea. Again, make sure that you get y by itself. 3x plus 4. Get y by itself, minus 3, and then graph both of them on the same coordinate plane. And positive 3, but you can also go down 3 and over 1. Honestly, the more points you draw, the more likely that you are going to have your solution within your points. Now that's not a perfect line, but I've drawn so many points that it's likely that I will be able to get, and back one, there it is. I'd likely get the ordered pair that would be a solution. Again, not my finest line, but I did get my ordered pair, and in this case, my ordered pair would be -1, 1. Do a quick mental check. Does that actually work? 6 times -1 plus 8. Yep, that's going to be 2 times 1. 4 times -1 plus 1, -4 plus 3. Yep, that works. Kind of do a quick mental check for these. And I'm going to pause and do a second one for the story problems. So that is it for the straight solving of systems by graphing.